Welcome back to the channel. So last time we finished up the displacer plates and the columns and the displacer disc and the plexiglass ring here. So now we're going to move on to this main frame. It's a 1/4 inch piece of aluminum, so I've got a piece roughed out and then I've marked it with some die chem. So this will eventually go onto here. So the first thing we're going to do is set this up in the mill. And get it machined in square to overall dimensions, to the main outside dimensions here. And then we'll scribe some lines and mark out for these holes. And I want to go ahead and drill these holes and countersink them. Some are drilled and then ringed. And then it gets a radius put here on the outside. So I'm going to go ahead and put that radius on it in the mill on the whole straight section. Then once we get that done, we will set it up in the rotary table and then we'll round these ends off. And then we can put the same bit in there and put the radius on the edges here, which will blend in with the straight section. So we'll get this set up, get it roughed into overall dimensions and get it laid out. Okay, so we got the main frame here finished up. It was a lot harder piece to make than it looks. So first thing I did is machined it to overall size, then did some layout lines on it. Then we drilled all of these holes except for the two big holes. And then we countersunk these for 256 screw. And then these are tapped for 256 here. This is for a 632 and countersunk in the middle. And when I machined it to overall size, I did go ahead and machine this radius on it here in the straight. Then I didn't want to lose my center punch mark here to line up on to do this radius in the rotary table. So that's why I didn't drill and ream these holes at the same time I was doing these on the bottom. So then we could set up on that punch mark. Once we centered the rotary table, then take an end mill, cut this radius here, and then put this radius on the edge here, flip it over, line up on the mark, do the same thing here. Then I set it back up and then drilled and reamed these holes here. This is 3/8 and this is 5/16. So this is what we end up with. Then I did a little bit of sanding and polishing to try to blend these cuts in here and these radiuses on the side. So what we need to do now is locate this piece on here and then transfer these 4 holes that this screws to this from the bottom. So the 4 holes that we tapped. And then this 5/16 hole here gets transferred. So I could lay this out with dimensions. There are no dimensions for this plate. It says to do it this way. I'm not crazy about doing it this way, but this is the way we're going to do it. So I need some way to line this up here, to line these 2 holes up so that we can clamp it down and then transfer these other holes. So to do that, I'm going to go ahead and make the displacer bushing that goes between these. It's made out of 3/8 Delrin, so it's 3/8 on one end, 1/4 inch on the other. So it'll stick into the plate and stick into this frame, and then that'll center our hole up here, and then we can line it up, clamp it down, and then transfer these holes. So we'll go ahead and make the bushing and then put the bushing in here and then transfer these holes, and then we'll get this mounted to the displacer plate. Okay, so I got the bushing made there, the Delrin bushing, and I was able to line this plate up here and then transfer the screw holes from there to here, and then bored and countersunk that. Then you can see how our rod goes through here, through the middle of the disc, so it'll eventually get epoxied to that disc. And there will be a plug here in the bottom. So that completes this part here, which is called the main frame. So there's 3 columns that'll be on here. One tall column in the center, which gets a bearing holder in the top of it to hold the crankshaft. Another column here, which will have the piston in it. And then another column here, which will have the crosshead in it, which will move the displacer disc. So we've got 3 columns to build, but the first thing I'm going to do is do the bearing holder that goes on top of the center column before we start on that. So that's a piece of brass. It's relatively simple. It gets bored through in the center. It's 3/4 by 3/4 by 5/8. It gets bored through in the center, and then counterbored for our ball bearings for the flange on there. Then we'll angle the top. We'll drill these holes first, and it gets 2 holes drilled down through it, and then it gets 4 ball end mill slots here on each side, kind of a decorative piece there. So the first thing we'll do, this is already nominal dimension 3/4 by 3/4. It's about 1 inch long. So the first thing we'll do is cut this off in the bandsaw. Then we'll get it all squared up, and then we'll make that bore through there for the bearings, and then we'll already be set up on center in the mill to bore this hole, so we can turn it up and then flip it around, and we can drill these 2 holes here for the mounting screws. And then there's 2 optional screw pads here that you can make that go in the top of those holes. It gets Loctited in there for the bolt, or you can just counter bore it and use the bolt directly in there. I think I will make these screw pads and put those in there and see what that looks like. So we'll get it cut, get it squared up, and get the holes drilled in it. Okay, that finishes up the bearing holder. So we squared this up in the mill. Then I drilled and reamed a hole through the middle here and then counterbored it for these bearings. There's a flange on that bearing that needs to be 35 thousandths deep in there on a counterbore, and luckily I had a counterbore bit that I was able to do that with. So then we flipped it over, took a ball end mill and machined these details here, these grooves on the side. Then after that, did some quick math, figured out what this angle was here on the top, flipped it over. Before cutting this angle, went ahead and drilled these holes, and then I get counterbored for this screw spacer here. Then set it up in an angle block and machined this angle off here at the top. Slide the bearings in there from each side. They're just a loose fit in there right now. And then made these brass screw spacers. It's just a round piece with a hole in the middle. And then made these screws here. So this brass piece will get Loctited eventually into here, into the top piece, and then see the screws stick through the bottom there. So this will mount on top of our center column and hold the crankshaft. So I decided to go with hex here on the screws. I didn't have any 256 screws that was that long anyway. And I'm pretty sure that the rest of the hardware that attaches the rod goes into the crankshaft, those will be hex. So that way everything will match, everything will be hex shaped. So that finishes this piece up. So next time we will start on the column that goes in the middle here, that this bearing holder mounts on top of. We'll get started on that next time. Thanks for watching.